Okay, for problem number 4, again, I want to point out we have a line. That line is y equals a squared x. We have a curve, it's cubic, y equals x times b minus x squared. We're told that these parameters a and b are positive numbers and that b is bigger than a. All right? What else we told? That these two curves, I should say the line and the curve intersect at two different points, p and q. And what did we determine? We've actually determined both the point P, which is below point Q, going left to right, and we also determined the tangent line at P. And certainly, I'll go to the whiteboard and I'll put that information down again for you, just to summarize what we do know. What I want to claim though is that the next question up, they said this tangent, right? We're talking about this guy over here, meets the y-axis at R. We'll draw that picture, by the way. It says the area of the region between the curve. Again, one point out the curve is this cubic problem, and the line segment OP. We'll draw a picture of that again. Is denoted by S, and we need to show this, by the way. All right, we need to show that. After we show that, we're going to get the area of the triangle OPR, denoted by T, and we're going to show that T is less than 3S. It's a lot, though. So I want to go to the whiteboard and kind of remind you what we did so far. And let's write this down for you. This is 4. And we know we have a line, and the line is y equals a squared x. We also have a curve, y equals, it's going to be x, b minus x, quantity squared. What else do we know? We know that a and b are positive numbers, and a is smaller than b. We know that much. Now, granted, we did a lot of work before, and I want to point out the work that we did. We graphed the cubic. It looks sort of like this over here. And again, I don't know exactly what the parameters a and b are, but I do know, though, that they're positive numbers. So something like this over here goes up like this. That's the cubic over here. There's a point over here. There's a point over here. Pretty easy to do, by the way. This point over here is b0. This point over here is 0, 0. We also know there's a line that has positive slope, and it looks sort of like this over here. We also determined that there's 2 points that they labeled. This is going to be Q, and that's going to be P. All right? What's Q? Let's write down what Q is. Q is a point, and that point is B plus A, comma, A squared. And we did this prior, by the way. It's not like I'm looking at this and know what that is. I had to do some work to get there. We already did that work, so I'm not going to do it again. And we know the point P. I'm looking at my picture, by the way. And that's going to be, you know what I think I wrote down? No, I didn't. P is, I'm sorry, B minus A. And again, we did this one prior as well. A squared B minus A cubed. All right? We also determined a tangent line over here. And the tangent at point P to the curve, the cubic curve, is going to look like this over here. And again, it's a ballpark picture. All right, ballpark. And they tell me this point over here is R. All right, so I'm looking at it, and I know there's a tangent point there, and I know there's a point R over here. You know what I'm going to do? I'm going to get my eraser out, maybe look a little bit neater. And let me just do that now. Give me 1 second to do so. There's a point R here, and so the tangent line. And again, I want to emphasize again that the line is y equals a squared x. That's the line. This is the line over here, by the way. And the cubic function is y equals, and that's going to be x, b minus x squared. And again, we know that a and b are positive numbers, and we know that the a is below the b. All right? Certainly makes sense in my picture and all. All right? Now, what else have we determined? What else we determined that the equation of the tangent line is y equals, and we determined this is A. It was work to do that, though. 3A minus 2B. And then it's going to be X. And we're going to get 2A, and then B minus A squared. So I know this point up here now. All right, what's the point going to be? It's on the tangent line, so it's going to be 0 for the X. It's a y-intercept, by the way. And you're going to get 2A, B minus A, quantity squared. All right? Now, someone says, I wonder what the question is now. And I got to go back and read. I just summarized what we know at this point. And I know the point P, I know the point Q. I know the general shape of this curve over here. I know the equation of the tangent line, and what I don't know is the question at this point. I can't remember, so I got to go back and look at it. And let me just read this. Closed tangent line. Going to turn the page over here. Let's take a look at this one. I got to read the question, by the way. The tangent line. I do see the tangent line. Y-axis at R. This is R over here. All right. The area of the region between the curve and the line segment OP. They're talking about this section here, by the way. And they're calling that S. All right? Question is, how do we get that area? Now, I'm going to say the best way to get the area would be by integration. So what I want to do is I want to write down what the integration looks like. And the integration is going to look like this over here. We go from 0, just along the x-axis, by the way. It's upper minus lower. What's the point P going to be? B minus A. The upper curve is that cubic problem. It's x, b minus x squared minus, right, the curve. I shouldn't say the curve, the line. What's the line going to be? It was actually a squared x. And then it's going to be dx. All right, simple integration. But I'll be honest with you, simple or not, looks like I'm going to have some trouble with it. And I want to kind of, maybe simplify it a little tiny bit. When I say simplify the integrand a tiny bit. And what would you get here? I'm kind of looking at it. I'm going to go slow. It's going to be x. This is going to be b squared minus 2bx plus x squared minus a squared x dx. Again, I'm going to try to, I'll look back what this is supposed to be. Right now, I'm not memorizing what it's supposed to be. I'm just going to do the integration, hope it's what they say it is. B minus A. And we get x cubed. I'm doing this x times that x squared. We're going to get minus, oops, sorry, I got in the wrong spot, don't I? So we're going to get minus 2b x squared. Then we're going to get plus b squared x minus a squared x dx. All right? Going to write a little differently. 0 b minus a x cubed minus 2b x squared. Then I'm going to put a plus down, parentheses. You want to get the coefficient of the x. It's b squared minus a squared x dx. Going to integrate. This is going to be x to the 4th power over 4 minus, well, that's going to be what? It's going to be 2bx cubed over 3. That's not so bad. Next up is going to be b squared minus a squared. Then it's going to be x squared over 2. The limits of integration go from 0 to b minus a. So I'm going to put that in now. And what do you get? You're going to get, let's write this down. Before I do that, I'm going to factor out the a common denominator, which would be 12. And I'm going to factor out an x squared. All right. You're going to get 3x squared, because x squared over 12 times 3x squared is going to be x over 4, minus, well, you're going to get an x, you're going to get a b, and you're going to get an 8. So 8 over 12, you divide by 4, it'll be 2/3. Looks pretty good. So 8bx. Then what do you get? Plus, well, that's going to be 6. And why is that? 6/12 is a half, and that's what I'm seeing over there. I factored out an x squared, so it's going to be b squared minus a squared. And I'm going to say we evaluate from 0 to b minus a. Let me just stop for a moment and make sure that's correct, by the way. Look at the multiplication. I would get 3 over 12, which is 1/4. I get x4. What would you give here? Minus 8 over 12, which would be minus 2/3, and we would get bx cubed. What do you get over here? You would get b squared minus a squared, x squared, and 6 over 12 is going to be 1 over 2. It works out beautifully. Let's keep moving. I'm going to evaluate this now. It's going to be b minus a squared over 12. This is going to be 3 times b minus a squared minus 8b b minus a plus, well, you know what? I'm going to factor out something on that b squared minus a squared. And I can write down as b minus a, b plus a. You may wonder why I'm doing that. I'm starting to see things now. And what am I seeing? There's a factor common to all 3 terms there. And what is it? It's b minus a. So you get b minus a. I'm going to factor that out now. That means I have 3 factors of them now, over 12. And what do you get here? You get 3 b minus a minus 8b. I factor out the b minus a, by the way, plus 6 b plus a. I'm going to still massage it. Oh, by the way, you may wonder why I'm not doing a 0. 0 would evaluate the 0 because 0 squared is 0, and 0 times any number is going to be 0. Okay, let's keep moving. What do you get over here? b minus a cubed. I'm going to put the 12 down like this, and I want to simplify what's in this bracket over here. That's 3b minus 3a minus 8b. Boy, this looks complicated. Plus 6b plus 6a. All right, let me get the a's together first. And what do you get over there? Let's see, 6a and 3 and minus 3a is 3a. That's not so bad. Let's do the b's now. 3, 6 is 9, minus 8 is 1. All right, I'm going to go back to the notes, by the way, and I want to see if that's what they said it was going to be. And let's take a look at it. And I noticed what they said, and this is what S is, by the way. They claim that S is this, though. And we'll talk about if it's the same thing or not. And they got b minus a cubed. That's their claim. Then they got 3a plus b. That's their claim over 12. Is it the same thing? It's the same exact thing. So our integration is good. Let me see if I met that. And it says the area of the region between the curve and the line segment OP is denoted by S. And we just verified that. So we just did what we're supposed to do. We showed that that's true, by the way. All right, let's go to the next question. The next question says the area of the triangle OPR. Well, I got to go back and I know it's a long process, by the way, but O, P, R. And the area of that triangle, right, the area of that triangle, right, is going to be 1/2 times the base. Well, the base is going to be the y value here. And what's that going to be? 2a, b minus a squared. Now times the height of it. This is the height. And what's height going to be? The x-coordinate of P, which is b minus a. All right? And that's what T is. Now I'm going to go back to the bottom of the page and write that down, by the way. So I'm going to write down T. Gee, I can't remember. This is what T is. Well, I'm going to say this cancels off. And what do you get? You get A, b minus a cubed. Okay. That's what T is. So T is A, b minus a cubed. What do they want me to show? They want me to show that 3s is greater than T. Well, let's write that down. What's 3s going to be? Well, I got the s over here. So 3s's would be what? B minus a cubed, 3a plus b. I'll multiply them by 3, so 12 becomes a 4. Greater than a, b minus a cubed. Now, inequalities are tricky, but I want to point out, thinking about it, and again, I want to point out, I've been told something before. What have I been told? And I got to go back and make sure I've actually been told that. I'm going to look back over and make sure that's written in the original statement of the problem, 0ab. I've been told this, by the way. So then the question is, b minus a, right, is going to be a positive number. So what I can easily, by the way, say is going to be a positive number. It's not 0, it's a positive number. So b minus a cubed is a positive number, and it's going to divide away. So I got this over here. What am I seeing now? 3a plus b over 4 is greater than a. I need to show this is true, by the way. You get 3a plus b, 4a. And what do you get over here? B is greater than, go subtract 3a from both sides. Now, bottom line, remember we've been told that B is greater than A. And that certainly holds, by the way. So another QED, by the way. We did what we're supposed to do. And we're done with that problem. Thank you.